Hi, my name is Mitchell Gumko, and this is week 14 for geology. And for this video, we're talking about the discharge experiment again, and we redid it and stuff, and did some more stuff. I'm sorry I can't have my face up there. I couldn't find a way to keep my face going with this presentation at the same time, so I was just going to do a screen recording. So we did the discharge experiment again, and we just did like more runs through it this time. And yeah, so you're gonna see what we did and everything about it. Let's get into it. So our goal for this experiment, the goal of our experiment was to find the average amount of discharge from the stream while changing one variable. The variable that we changed was the width of the canal from 4 inches to 2 inches. Now, we just want to keep one variable changed because when you have multiple variables changed, you can't really tell if which one is doing the effect. So by changing the size or the width of the canal, we thought that this would give us ability to see, will this make objects move faster down the stream if they have a bigger canal width, or would they move slower down the stream with a bigger canal width, or smaller, or vice versa. So yeah, that was the one object that we changed. Now, as you can see, this is what the canals looked like. They're 4 inch. That was the 4 inch one. So the way we collected our data was, well, we had a phone for a stopwatch to do the time. We had tinfoil, which you can see, which was our canal. We had ping pong balls that floated down the canal. That was the object that we were timing to see how fast they would go through the canal. We were seeing if that's how we were measuring which canal was faster, which canal discharged the ping pong balls the fastest. We used a piece of pre-cut wood to form the canal to make it nice, so it wouldn't be floppy or it wouldn't be uneven formed. One canal is a little formed stronger, the other canal is a little flat. No, we went to use the pre-cut wood, so they were both the same, so we don't really have to worry about the variables changing on that. And then we used a hose to be the stream through the canal, the water flowing through the canal. Results. So with the 4 inch canal, the average discharge time was 1.78 seconds. And with the 2 inch canal, the average discharge time was 1.8 seconds. So as you can see, the smaller the canal width was, the faster the items were going through. And so that was our results with it. As you can see, we have two photos of the canals. I believe this one, it's kind of hard to tell because they're tinier, but I'm pretty sure that's the 4 inch canal, and that was the 2 inch canal. So smaller the width for the canal, the faster the items are going to go through the canal. And this is we marked it down on a piece of paper. This is data set 1 up here, the first row. So you can see that all the times that, we did it 10 times. And for data set, or for canal inch 4, which is this one, and this is canal inch 2, as you can see that each time it didn't matter, canal 2 was always faster. But just that was how we collected our data on that piece of paper. So our interpretation of this whole experiment was that, yeah, we figured that with a smaller width for the canal, the ping pong balls would flow faster through the canal since the water had less space to spread out. So what we mean by that, and the reason why we interpreted it and why we kind of figured that would happen, was because when you have a wider space of range, the water can spread out more, especially when it's all the same depth of the water. Like, it's not like, oh, well, there's a hole, it's all flat. The water will spread out more, so leaving less force behind it. It doesn't have as much force when it's going downhill because it's so spread out. But when it's in a closer range, in that smaller canal, the water is kind of stacked on top of each other. Like, the thing about it's the same like width and everything, but it has more power. It's going straight down. It doesn't spread out and go. I guess that's how we kind of thought about it. Like, we just think, oh, it just goes, where like it has to spread out. And the other one, even though you don't really see it spread out because it's just a constant flow, but there's not as much force behind the farther spread out one because it's not as tight and compact. So the water isn't as necessarily strong when pushing objects down, even though it's the constant flow of the hose, but the hose can spread out more, leaving the water or that canal with less force in it to discharge items. Future work, things that we might change in this project in the future if we were to do it again. Change the length of the canal. We think, we're not sure if that will change the speed, like change for 4 inches, I guess you could say, to like maybe make it closer or not slower. I mean, we figure it would probably still be slower. It just would be a wider range of speed difference. Change the canal from 2 feet to 10 feet, just to see what could happen. But keep the length the same, but um, keep the length the same for each one, I would say, and keep the width the same, but change the length of the canal longer and with the same width to see something that could happen, or even just change the length of the canal. Then you probably know the shorter one would go um, faster. But just changing the length of the canals, maybe having two different widths and two different lengths. See what kind of happens with that. Yeah. Put other objects in the canal than ping pong balls. Throw in like battle caps, pieces of paper, uh, other things that could float down there, just because to see, what happens when we do use something else. Was it just because ping pong balls did this? Would a bottle cap be the same thing? Most likely it would, but it'd be fun to change that in the experiment and see what happens. Thank you for listening to my presentation. I hope you learned a lot about this discharge and have a great week.